A line has an x-intercept of 12 and passes through the point 4, 10. We need the y-coordinate of its y-intercept. How can two pieces of information reveal the other intercept?
The answer choices are 12, 27, 18, and 15. Before calculating, let us translate every phrase into an exact point on the line.
The line passes through 4, 10, so I know 1 point. But I almost want to call 4 the x-intercept and 10 the y-intercept because they are the point's coordinates.
That is the key trap. An intercept is not just a coordinate copied from any point. It is where the line crosses an axis, so the other coordinate must be 0.
At the x-axis, y equals 0. Therefore, an x-intercept of 12 gives the point 12, 0, not merely the number 12 floating by itself.
At the y-axis, x equals 0. If we call the unknown y-intercept b, that second axis crossing is the point 0, b.
So the same line contains 3 useful points: 12, 0, 4, 10, and 0, b. We only need a linear relationship that connects them.
Because both intercepts appear directly, intercept form is efficient. A line with x-intercept and y-intercept b satisfies x over a plus y over b equals 1.
Here the known x-intercept is 12, so it equals 12. The equation becomes x over 12 plus y over b equals 1.
Now use the fact that 4, 10 lies on the line. Substitute 4 for x and 10 for y. This creates one equation with the one unknown b.
4/12 simplifies to 1/3, so 10 over b must supply the remaining part needed to reach 1.
Subtract 1/3 from both sides. 1 minus 1/3 is 2/3, so 10 over b equals 2/3.
This is where I need to be careful. 10 divided by b equals 2/3. I should not simply divide 10 by 2/3 and lose track of where b sits.
Cross-multiply to preserve the equality. 10 times 3 equals 2 times b, giving 30 equals 2b.
Divide both sides by 2. That gives b equals 15, so the y-coordinate of the y-intercept is 15.
Let us pause before choosing. We can verify the result by placing b equals 15 back into intercept form and testing the given point.
With intercepts 12 and 15, the equation is x over 12 plus y over 15 equals 1. Substituting 4 and 10 should make the left side exactly 1.
4 over 12 is 1/3 and 10 over 15 is 2/3. Their sum is 1, so 4, 10 really does lie on this line.
The intercepts check too. Setting y to 0 leaves x over 12 equal to 1, so x is 12. Setting x to 0 leaves y over 15 equal to 1, so y is 15.
A second method confirms the same answer. Use the points 12, 0, and 4, 10 to find the line's slope.
The vertical change is 10, and the horizontal change is -8. Therefore, the slope is -10/8 or -5/4.
Start at the x-intercept 12, 0, and use point-slope form. The line is y equals -5/4 times x minus 12.
At the y-intercept, x is 0. Substitution gives -5/4 times -12, which is +15. Both methods agree.
Now compare with the choices. 15 is choice D, 12 is the given x-intercept, while the other numbers do not satisfy the line through 4, 10.
My reusable strategy is to translate each intercept into an axis point. Choose intercept form when both intercepts matter, substitute the known point, and verify that every original condition holds.
The line crosses the x-axis at 12 and the y-axis at 15, while passing through 4, 10. The y-coordinate of the y-intercept is 15, choice D.